Don't watch this video until you have an answer. So here's the question. Given this right triangle with a hypotenuse of 10 and the height of 6, then the question is, what is the area of this triangle? Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so don't watch this video until you have or you submit your answer in the comment section down below. Alright, so now, before I talk about the area or the answer to this question, let's have some review first of some concept. And that concept is the inscribed angle theorem. So what is the inscribed angle theorem? So here it is. So the inscribed angle theorem says the inscribed angles subtended by the same arc are equal. That's the first one. The second, inscribed angle in a semicircle is always 90 degrees. That is the second one. The third one, an inscribed angle is half of the central angle that subtends the same arc. That's the third one. But here, we are interested in the second theorem. So it says that inscribed angle in a semicircle is always 90 degrees. So if we draw a circle like this and draw its diameter, we can draw a right triangle right about here. And this angle right here must be 90 degrees. We can put this 90 degrees over here and still this triangle is a right triangle. Now, one question here is, what is the maximum height of this triangle that is perpendicular to the hypotenuse or simply the diameter of this circle? So this is not the maximum height. This is not also the maximum height. But the maximum height occurs when we have a right triangle like this, or simply these two sides are equal, or we have an isosceles right triangle. And we can say that the maximum height must be equal to the radius of this circle, or simply half of the diameter of the circle. So this concept is very important later on. So now keep in mind that the maximum height of a right triangle must be equal to half of the diameter of the circle. Alright, so now, going back to our question. So why is this concept very important in this kind of question? So we have inscribed angle theorem for circle, but we have a right triangle. Now what we're going to do is to put this right triangle inside the circle, like this. Now we can say that the diameter of this circle must be the hypotenuse of this right triangle, which is equivalent to 10 units. And the maximum height of this right triangle must be half of the diameter of the circle, which is equal to 5 units. And on our given, the height is 6 units. Therefore, this triangle does not even exist. Therefore, if we want to find the area of this triangle, then the answer is the triangle does not exist. Therefore, the area of this triangle does not exist also. Therefore, the correct answer to this question, what is the area of this figure? This figure does not exist. Therefore, the area of this figure does not exist also. And as always, we are done.